Hi everyone. Appreciate watching this video and for the amazing opportunity of AI/ML. So in this video, I would explain you about my introduction first, and then I would deep dive into one of the crucial skills into AI/ML data science, which is how to design and optimize ML models for real world scenarios. So by the end of this presentation, you will have a systematic approach that prevents 80% of common ML project failures. So let's start with my introduction. Hi, I'm Palash, and I have over 15 years of experiences and over 8 years of experience into AI/ML. However, I have worked on site in US for 3 years. I worked with Microsoft M365 for Exchange Online, focus inbox into AI/ML. I've also worked with Social 27 virtual event, which was built into Gen AI. In that, I developed a critical feature called gamification. And other than that, I also worked with a fintech organization called Magneti, which is a product of First Abu Dhabi Bank. In addition to that, I also worked into with Measure One, which is a data as an infrastructure model. And in it, we have built into Pixie Parser AI, fine-tuning the GPT-4 model. And it's built in Python and ML code is done in PyTorch. In addition to it, my last organization is into compliance, which helps in achieving compliance like SOC 2, Type 1, Type 2, HIPAA, GDPR, ISO. In that, it was built into Gen AI, recommending the clients for the kind of evidences that is required once they onboard into the platform. So let's begin this presentation video wherein I will walk you through the approaches that we face on a day-to-day basis into ML models. So let's go ahead and let me share my screen and walk you through it. One second. Mhm. Okay, hope you're able to see my video here. Okay. So in this, we would discuss about the machine learning model design and optimization. As I was just mentioning about having those ML project failures that we have, which will help you to follow a systematic approach while designing AI ML for any project. So let's begin an example with scenario starting with you understand most of the CEO walks in and suddenly decides that we need to implement AI into our system. That sounds familiar, right? So this is how exactly AMLET project begins. But then it starts with a business problem, not the technical specification. So in this PPT, we would deep dive into such MS specification, what exactly is required. So I built this presentation that would start with a problem and then defining an idea into building a production ready models for you. So in this particular presentation, what you will learn is how to approach those real world ML problems systematically, when to choose regression and classification. We know these are two very key parameters into AI/ML. So we have to identify which way should go. Is it based on regression or is it based on classification? The proven optimization techniques that actually work. So let's deep dive into and go into the slide two. So in the world of e-commerce, you see, as I was just mentioning about integrating AI ML, that starts with a business problem, but then you have to handle it on a technical point of view. So generally, when we talk about e-commerce optimization, what that generally the business goals is, we have to predict those customer purchase amounts, the customer lifetime value, identify those customers who are likely to churn, personalize those product recommendations by seeing the purchase history of that particular customer. And then we have to optimize those marketing spends. The data that we have, and this data, very important data, which would definitely come into existence into initial and an analysis of a particular ML model, which models to choose, that all starts with the data collection over here. So the data that we have is the customer demographics, the purchase history of that particular customer, the website behavior, and the marketing interactions. Now, the $1 million question arises here. How do we turn this business problem into a machine learning solution, right? And so what generally happens is I have seen teams spend months optimizing algorithms or better feature engineering would have given better gains. Start with these fundamentals and you will outperform most ML practitioners who jump straight to the complex stuff. So let's begin with this particular slide, which is more of a problem classification in identifying those decision tree approaches. So the business question that arises is one of them is regression. How much will they spend? Another is classification. Will they buy or the customers will churn? So these all starts with this decision tree approach, and that starts with the problem classification. Now, when we think of this regression, the regression examples can be predicting those purchase amount, the lifetime value of that customer. So any customers would have a lifetime value based on the series of orders the customers went through and the time until next purchase. So it's generally a regression behavior that we have to predict those algorithms, how what's the frequency of the customers until the next purchase. The classification examples, as I've said, most are those are as the name suggests, it's based on the classifications, like will the customers churn, the customer segments, what customer segments they belong, and the product category preferences of those customers. So these are all classification of that particular customers that starts with it. So here's where most people get stuck. The key is asking, am I predicting a number or a category? If an e-commerce wants to know how much someone will spend, that's regression. If they want to know whether someone will churn, that's classification. So just take a moment to think, which would you choose for each of your business goals? Is it regression or classification? Let us know about that in the next slide. So, so, so let's start with the systematic approach to it. So, any ML model will go through all this 5-step pipeline, and that starts with preparing those data, the data that we have, and then doing data collection, data filtering, data validation. Now, what happens is when you gather all this data, you have to do a feature engineering after the data is validated, after the data is filtered. You have to implement those feature engineering on what key parts of that data is required to build this ML model. So once you have identified all those data into engineering implementation, then you have to do the selection of models in any ML pipeline. Once the model is selected, then you have to validate and train those data based on your requirements, based on your business requirements, based on your engineering requirements. Once the trained data is trained and validated, you have to deploy it, and then you have to evaluate and optimize those data based on the needs. And then at the end, you have to keep on monitoring and with the help of analytics, and you have to refine the model based on the key metrics, the positive, true positive, or false positive that you collect those data from the marketplace or from the customers. So that's how the entire pipeline starts right from the data preparation. So 80% of your time should be in steps 1 and 2. As a software engineer, you must have learned the more time you invest into analysis and understanding, it would have a less hassles into actual implementation. Same goes into ML pipeline. The more time you give on data preparation, from data collection, feature engineering, that you would have a clean data that beats fancy algorithms. So there are 2 steps to it. Either you have a clean data, the good data which I'm talking about, and simple model, which would always be greater than if you don't focus on those data and then later on doing those complex algorithms and complex model. That would equation would never fail. So that's the priority over here. You have to have your most investment into step 1 and step 2 about having those clean data. And then once the step one and step two is done, step three is often kind of determining like which algorithm choice matters, which should be less hassles as compared to the one when you put your last focus on step one and two. Step five is where the magic begins. So this separates good from great models. The reason being, as I've said again and again, the more time you invest, it would have less hassles on step five, and you would actually see those magic. The AI started prompting those requirements or needs from you, and you see the model being turning into a true positive most of the times, and you're reaching accuracy close to 95%, 95 to 98%. So that's the goal over here. And again, like here's my battle tested framework as well. I've used this on projects for fraud detection to recommendation systems. Notice the emphasis on data preparation. This is where most beginners rush through, but it's actually the most critical step. And that you will be seeing in the next slide. Okay, see, the next slide, you will understand mostly about the customer churn prediction, which customers will cancel their subscriptions next month. So that's a more of a prediction and the classification issues. So the data sets that you have is this is basically focusing on e-commerce, and as an example scenario, you have a 10,000 customers. The 15 features with that includes the demographics, usage, and billing. The target is churn, and the class imbalance is 20% churn rate. The success metrics that is identified as precision or predicted churners, how many actually churn. Of actual churners, how many did we catch? So the AI needs to be catch how many churned actually on that particular segment, and the F1 score, which is a most of a balanced measure, right? So here you see as most of the time, uh, you will get your hands dirty over here because you will now see a real churn prediction model. This is the type of problem that directly impacts business. Every customer we save from churning would be worth thousands in revenue. So that's the end goal over here. So let's see where the magic begins. So here you write a piece of code which is kind of handle missing values, that sum, and then doing the feature engineering as a step two. Here, what we did in the step one is about data identification, data collection, and in the step two, we start with the feature engineering part. The step three is about the algorithm that we talked about. Here we have implemented scikit-learn, which is a single piece of code. We have imported that library, label encoder, and then we have integrated all these different parameters about the gender, the partners, the dependents, and the phone service for that particular category. The feature engineering over here is what works in most of the part is ratios. So we have to check those logical ratios. What are the spans versus the tenure? What was the tenure of that particular customers versus the spend? The time-based features, the interaction terms, and the aggregations. Common mistakes that generally most of the engineers do in this particular part is ignoring those data leakage, over engineering features, which was I was referring to about the complex algorithms that we generally do, not validating assumptions. So assumptions play a key role identifying those risk analysis, the assumptions, and then forgetting the domain knowledge. So you have to understand if it's an e-commerce, what are those features, what are those predictive churn rate that can arise from the customers, what are those interactions or engagements that generally happens. All of those key ideas should be in your mind while you're working on this AI ML model. So domain knowledge holds a very key factor in over here. So this is where you see those tenure per monthly charge feature. That single line often improves model performance by 10 to 15 percentage. And you wanted to know why? Because it captures customer value density, customers who stay longer relative to what they are paid different from high paying short term customers. So this is domain knowledge translated into features. So let's move on to the next slide, which is about training the model and selection of those models, right? So the model selection strategy starts with very simple. It starts with the logistic regression baseline, adding complexity to it. So ideally, we start with random forest and XG boost, validate properly. So we do a cross validation always, and the business context always matters. So the crucial insight, if I have to say over here, is the logistic regression. Why? Because it's fast, is interpretable, and often performs surprisingly well. So if a simple model gets you 90%, there why to add complexity to it. So that's in this case, we have used random forest because it gives us a meaningful improvement, and that extra complexity is justified over here. So we have added random forest over here. And the result preview is the baseline logistics and the training time. It's quite lesser than 2 seconds. For random forest, it's the training time is 15 seconds. And I've just told the reason why we have choose random forest because it's a combination of both. It also includes the extra complexity in case it arises. And so for that particular meaningful improvement, we have added random forest over here as a complexity model. Okay. Okay, so the step three that often works over here is the optimization hierarchy. So the high impact value, which is better feature engineering, handling class imbalances, cross-validation strategy, and proper training, validation, test split. So A and B testing, which we do generally. And the medium impact, if we have that extended amount of time period, we can do hyperparameter tuning, we can do feature selection, we can ensemble those methods, we can also utilize different algorithms and try and test it out those algorithms features. So we can utilize all these high impact values first, and that would help uh, your months of frustration. So most people jump straight to hyperparameter tuning. That's like polishing a car with flat tires. Fix the fundamentals first. What I would recommend, that class weight you see in that particular code, the class weight which is equals to balanced parameter, it just improves our F1 score by 8 points with just one line of code. So that's more impact than hours of hyperparameter tuning. So what I would recommend over here, instead of directly jumping into hyperparameter tuning, you need to understand those fundamentals and fix those fundamentals first. Identify what's the classification here, what's those balance parameter here, and then integrate those line of code so that your accuracy improves for that particular ML model. So the results that we saw from the last slide is 67% to 84%. That's more of an optimized model, the baseline model wherein people focus more on the hyperparameter tuning. That's a baseline model where we achieve a maximum of 67%. But when you do all those fundamentals first, fixing those lines of code, optimizing that model, that increases your efficiency to 84%. And the business impact out of it is millions of saved, 15% of customer retention, decrease in false positives quite close to 30%. So what drove those improvements over here? Technical wins, which we can discuss, like class balancing, the feature engineering, because we have invested more time into step one and two, the algorithm choice, because it made our life easier by having those meaningful data and improvements. The translation into business happens because of the higher accuracy. We got kind of higher number of churners who used to churn. The precision, which means like minimizing those false alarms. Return of investment is of course a higher margin, 15:1, which is pretty good. Which is pretty good. The common pitfall we should avoid over here, the accuracy that we always determine, saying that 95% is not equal to good rate with 20% churn rate for everyone gives 80% accuracy. So what we learned over here is our model went from catching 63% of churners to 87%. That's a massive business impact. But notice something crucial. The biggest gains came from handling class imbalance, not from complex algorithms. This is the pattern I see repeatedly across industries. So that's the main agenda over here, identifying those class imbalances instead of writing those complex algorithms. So that's where your focus should be right into step one and step two. Key takeaway next steps. So what we understand from this is the three pillars of ML success includes the problem framing, which is understanding the regression and the classification and the context of the business first. Here in this case, we wanted to identify the churn as in kind of e-commerce domain, the data quality, the quality of your data, focusing on step one and step two. 80% of your effort should be there, which eventually identified as an feature engineering win when you invest your that percentage of effort. This path optimization, that is, fix the fundamentals first, measure what matters. So that's the optimization part. So the three pillars are problem framing, data quality, and smart optimization. Um, Again, as I mentioned, just over there, avoid this mistake, jumping to complex algorithms first. It, our focus shouldn't be writing complex algorithms. Our focus should be having those meaningful and impactful data. Ignoring class imbalance, you shouldn't. Using accuracy for imbalanced data. Skipping cross-validation, not translating to business value. You always have to understand what's the business value that is asked. What should be your next steps? You should practice with Kaggle datasets, focus on one domain deeply, build an end-to-end project, learn SQL plus feature engineering, and understand your business context. So keep at least one business in mind. Your ML journey starts here, which is kind of picking one data set, apply this five-step framework, and focus on feature engineering. You will be surprised how much you can achieve with the basics done right. So I would recommend you start with at least one data set and implement this five-step ML framework, which I've just demonstrated, and see how the result is for you. And shoot out me an email or message and let me know how it worked for you. I'm sure it would be amazing for sure. And that's how we complete our presentation as well. And it's nice to have you all over here, and looking forward to an exciting session next time. Thank you so much for your time.